Find the derivative. F of x equals 4x minus 6 times the quantity 5x plus 7. In order to do this, we have one of two routes. One is to expand the polynomial. So that's pretty straightforward. It would just involve multiplying out. 4x times 5x would be 20x squared. 4x times 7 is 28, so plus 28x. Negative 6 times 5 is negative 30x, and minus 42. So this would be 20x squared minus 2x minus 42. And its derivative then would be 40x minus 2. And that would be perfectly fine. You've got the derivative. That's a perfectly valid method. It's just that not every kind of function can be multiplied that way. And so you at times need a method of finding the derivative without expanding first. And that's when we use the product rule. The product rule says whenever you have a function of the type, I'll say f of x equals g of x times h of x. The derivative of that thing is going to be the first times the derivative of the second plus the derivative of the first times the second. And what's nice is because the order that you multiply things and the order that you add things doesn't make a difference, it doesn't matter if you mess the order of this up. So as long as you get the derivative of one times the function of the other, you're fine. So the derivative here, I'll do the first times the derivative of the second plus the derivative of the first times the second. And of course, we would need to simplify, although this is completely equivalent to this derivative here, as I'll show. But let's see, 4x times 5 would be 20x minus 30. And 4 times 5 is 20x. And 4 times 7 is 28. Looks like familiar numbers there, I would assume. So we have 40x minus 2. The same derivative either way. If I had a preference, it would be to use the product rule.